Definition is an abbreviation.
Yeah, okay, that's not right.
Okay, that's interesting. Nick's like, hey, you shortened definition. Maybe you weren't allowed to in your class use abbreviations. That's possible. I actually don't know.
Mr. Chale went systematic. He's very strict.
That's not what I was thinking of.
Yeah. Now Mr. Chale has a Tide Pod on his desk. It's very funny.
No one has found the illegal thing yet, huh?
It's on his desk, it's just sitting there.
I have this, but one of my kids like half broke it. So it's kind of sad.
I like it.
He's like breaking.
It's like,
They had too much fun.
That's what we do.
I had a little baby one. I don't know where he went though. Someone gave me a little baby one. I think he's lost. He is really cute though, if I can find him.
Mr. Chale would always
Literally all these.
Only I had hair like Mr. Chan.
Is it the
And was Asian.
You know what? No.
Ooh, another idea with the H on the outside. It's weird, but it's actually not illegal. But keep thinking. It's weird, it's just not illegal. You guys will all know it as soon as I show it to you. Come on.
The smartboard.
No, because this was actually, well maybe, okay, it is possible. Lainey's like, wait, writing it this way might be illegal. You might have seen it this way. There is another way of writing the formula, so it is possible that you didn't see it with this orientation. Guys, do you see how I'm just flipping every single one?
Yes, ma'am.
The reciprocal of every single one? What I do to one side, do to the others? It's legal. So maybe you didn't see it this way. What I like is, I really like this form with the side on top. If I'm missing a side, I'm going to have the side on top. Because then I can move this number and I'm done. So I like having the side on top if I'm missing him. I like having the sign of the angle on top if I'm missing the angle, because then I can just move the number to the other side and solve. So that's why I like seeing it both ways, because you technically can do it both ways. And I like having the unknown right up here, so all we have to do is multiply and I'm done. Okay, that's possible you saw it differently, but it's not illegal. There was something that was super illegal when trying to prove triangle congruence in geometry.
SSA. Yeah.
What?
Yeah. I knew I would get
SSA,
it.
you were never allowed to use SSA or ASS.
So.
Most geometry teachers teach it that way. Bible uses it. Anyway, coming back. Stop talking about donkeys and come back. So, SSA was always illegal in geometry. It never could prove congruence. Now, neither could the AAA. It couldn't either. But I would have AAA up here because it's not possible to tell anything. SSA, we're going to see, is what we call, I want you guys to put a quick little circle around him.
The liar.
To remind yourselves that he was illegal in geometry. You're a little older now. A little wiser. Sure. A little more mature. Anyway,
Exactly.
we can do something with this guy.
I was white.
And I'm going to show you. I'm going to show you why you couldn't prove congruence with it in geometry. It wasn't because they were never congruent if those were the same. Sometimes they could have been. But sometimes they might not have been, so it was not able to be used as a, hey, check it, if it's there, always congruent. If it's not always true, then why use it as a proof? Or for a proof? So it would not have been, it is not enough to prove congruence. These ones are okay, those ones are okay, the other ones we talked about, SSA and SAS, all of those were good for congruence. And the reason being, if you had any of those pieces of information, it only pointed to one possible triangle. And so if two triangles had those pieces of information, and there's only one possible triangle that can result, well, then they must be the same. They must be congruent. Everything must match. The AAA will never work because we have no idea the size unless we know a side. So that's why AAA was only enough to prove similarity, but not to prove congruence. SSA is sometimes pointing to two triangles, one possibility each, but SSA actually, sometimes no triangle is possible, which you guys saw in geometry from time to time, not a possible triangle. They give you like 3 sides. How do you know if it's a possible triangle or not? Anyway, sometimes SSA is not even possible, and then sometimes there are two possible cases, and there's no way to distinguish which one is the one they're referring to. And then other times there's only one possible triangle. That's the tricky case. That's the case we might have to save till Monday. But the other stuff, for all the normal cases, AAS and ASA, we can go ahead and use law of sines. And guys, check out real quick. Law of sines. Even though there are three sides, three equivalent statements, we can only take two at a time, like a normal equation, right? Even though there are three equivalent statements, we can only take two at a time. Which means we need an angle matching with the side and an angle to find the side, or an angle matching with the side and the other side to find the angle, or two angles and a side to find the side. I think I said one twice, but that's okay. So I need two statements at a time, everything plugged in, but only one missing to solve. So let's take an example. What if we have AAS? Once again, we're not proving congruence. We're saying if we have AAS, that's enough to finish the triangle with law of sines. That's enough to solve for what's missing. So first of all, let's identify what is missing, what we have to solve for. Take a second, get down your example. I just cut off the page. Struggle. It is me. Christine's still gone. Okay. No, we've already talked.
Leo, where's Leo?
Leo's gone, but he was here yesterday.
Leo ran away.
Joe Brazel's still gone. Okay. Mari just talked to me real quick after, so Linda can make it. As you guys get the triangle, think of what's missing, first of all, that we want to solve for. Not everything. I see three things that we already know.
There are two sides that are missing and an angle.
Nice.
Whoa.
Two sides and an angle. Thinking of the letters, I'm missing angle A and side.
B.
No, actually I know B.
Side AC.
Side A and side C. Or you can say side BC or CB and side AB or BA. So Christine's still gone. Yeah, flu hit her. Stinker. And then Leo's gone. Anybody else additional gone from the people yesterday? I think it's just Leo.
Leo.
And then Joe and then. Okay.
Leo understood.
That sounds horribly tragic. That sounds weird.
I agree.
Okay. So, you guys should be looking at that formula and saying, all right, P.S., if you don't have your calculator out, you might want to grab it out because these are not necessarily unit circles, so we're just going for it with our calculators, yeah?
Whoa.
We need angle A, we need side A, and we need side C. Remember, in geometry, capital letters stand for angles and lowercase letters stand for sides. You can use like 2 points and like little notation with the bar on top, but life's too short. Calculator's out because we can't just take one person's word for it because we all know that there are silly mistakes that can happen when you're doing calculations, right? Okay. Question. What's the easiest of these three pieces to find?
The angle.
Yeah, because if you're given two angles, just do 180 minus both of the others, right?
Yes.
And can't you type it all in one line and just do minus 105 plus 45 in parentheses? Ooh. Angle A is 30 degrees. Okay.
Uh-oh.
I'm just going in order of what I wrote, so let's just solve for side A next so that we're all on the same page. According to law of sines, if side A is missing, wait, did I tell you guys my trick of put the missing one on top?
Oh.
Okay, so check out the formulas. Which ones am I going to be using? A over. Good.
Oh.
Sine of, okay, remember, A is the side opposite angle A, which we just found to be 30 degrees, right? So sine of
30 degrees.
equals, oh, let's put C because we're missing him too. That sounds fun.
Oh.
Oh, what? No.
Because then I can't solve for just one, right? So who do I need to use on the other side?
B.
Yep. And B is 5?
Yeah.
All over sine of 45. Now, ironically, this is a totally unit circle expression, meaning we can multiply the sine 30 and plug in unit circle-y stuff, but since we're about to get to 105, that is not a unit circle angle, we're going to use our calculator anyway. Let's go ahead and solve. Wait, what am I solving? Because everything isn't to one side yet, is it? Then how am I getting negative 5.8? I'm in radian mode. If you get a negative number, that's a bad sign. Go change to degrees. How do I know the answer is 3.53? Check me. 6? Anybody else get it? Pause. We left some people behind. How do you solve for little n?
I got, not that.
How do you solve? Hold on, pause. Let's make sure what we did. Because we got to get A alone. I did it in my calculator, but I didn't show you how to do it. How do you get A alone? Yeah. I like them on top because we just have to take this division and multiply. So we're going to multiply sine of 30 over on this side, and when we multiply, we get rid of him apart from or away from the A. He's now over here. Do you guys plug in 5 times sine of 30 over sine of 45 in degree mode? Nice. Matched up? Cool. So you guys solve for C. Go. Do what you got to do. Solve for C.
What'd you get?
3.53, 5533906. Solve for C. Set up a formula. Just to keep it honest, there's so many little mistakes that can happen. So don't try to do everything in your head and then not show your work and then you make a little mistake on a fairly simple problem if you've just written it down. Yeah.
I thought A over sine of A equals B over sine of B minus C over sine of B.
Oh, no, equals. Meaning, there are 3 different equivalent statements, so we can set this guy to that guy.
Oh,
But if we don't have that information, we can set it to that guy. So they're all equals. Does that make sense? Yeah, that would totally mess you up. Sorry. You guys get that? They're all equals. I can do this with this, or this with that, or that with that. I just need 2 of them to set equal to each other. And make sure they're set up with the same orientation of the sides over the sine of angles, or the sine of angles over the side. Okay, now pause. Ready? I'm going to show you the final answer, and here's a dilemma. You could be very, very close, and yet I would take off points. You could be very, very close, and yet I would take off points, unless you have this exact answer written. You ready? Make sure I did it right, or else that'd be really awkward. Good. 6.83. You could write a 0 or not write anything at all. But if you had any other number in this space, unless it was a blank, if you had 6.831, if you had 6.832, if you had 6.29, if you had 829, I would say it's a little bit off, Chris.
The example says to round to 2 decimal places.
True, except all year we've been using 3. So I guess you could do, well, the nice thing is 8.3 would be the same thing. So my point would be if you have 6.84, 6.82, or 6.81. So thank you for the directions. Technically, when you're solving in Calc Chat, 2 decimal places will always be what the book shows, and that's good. But I'm preparing you for calculus where we always have to round to 3. But okay, let's say we round to 2, because that's what the directions say. Thank you, Chris. Still, 6.83. Did anybody get anything beyond 6 or besides 6.83 but close? Yeah, what'd you get, Michael?
Wait, I got 6.829, but you guys rounded up, right?
Okay, so if you rounded up, he'd be all right.
I got exactly
6.83 exactly?
30, yeah.
Okay. I'm just trying to warn you guys, and here's what my warning is. For most of us, it ended up okay. Even Michael was a little bit off of 6.829, which if he had written that, I would take the point off. But if he had rounded to the 2 places and it ended up being the same, I wouldn't have known necessarily. Would have seemed right. How did you need to solve this answer? Why did I use the 5 and the sine 45 over again? Some of you decided to use this guy. Somebody's wrong. What happened?
Rounded.
Oh, sorry. Yeah, good job. He's rounded. If you use a rounded answer to find another answer, what are you incorporating into the next calculation? What are you bringing in? Error. So here's the dilemma. If you wanted to use this guy, what would you have needed to have done? you probably would have been okay if you had kept your calculator with the long expanded version, and if you had typed in 3.535533906. That probably would have worked fine. Or you could have scrolled up and stolen them. You guys know how to do that, right? Scroll up and steal them. And with an old calculator, do second enter, second enter, second enter, and you move up the list. So Ryan, that would be for yours. You can do second enter, second enter, second enter. That's the old-fashioned way of doing it. So you can go steal it. But long story short, if you want to use this guy, don't use the rounded form that you put as the final answer. Use the full expanded form. Not full. It's actually still rounded right there. But the expanded form, the extended decimal, that way you don't introduce error, at least not up here in the decimals where you're going to need to round. So, what would have been easier to do? Use the nice guy. That would have been easier. And watch out, because those of you that did use the rounded one, from time to time, you're going to get it a little bit wrong. Okay? Another one. Ah, there's no picture. If you're a visual person, draw a random triangle ABC and plug in stuff, and that'll help you. If you're not so visual, or if you're like, wait, I can follow patterns. I see who's there and who's not. Maybe you can figure out that your missing ones are angle, missing ones. Angle C,
Side A.
side A, and side B. So if you want to try it without a picture, it's not necessarily bad or wrong. You can use just the letters themselves and like, oh, it's an ABC and I have angle A, angle B, I'm missing angle C. I'm missing A, I'm missing B, side A, side B, but I have side C. Some of you go for it, but those of you that are visual, no stress, take a second. Think an ABC, fill it in. Now what's it going to be? Once you're ready, go for it. I'm going to have you guys check in your groups in just a few moments, so go ahead. And if you don't have a calculator, no big deal. Set learning is a little sad, but set up the formula. How would you solve? What would you plug into your calculator if you had one? And then in just a moment, you can check with your group members that do have a calculator if they plugged in the same thing you would have and what that answer is. Alright, groups collaborate. I hear a couple of you whispering, but go ahead and check with each other. You might not have plugged them all in the calculator, but you can work on that together, making sure you put it in correctly. But check in your groups if your expressions are right, if your setup of plugging in the formula is right. Okay. You guys are all not talking to your groups today. Be nice. Come on, reach out. Go. Go, go, go.
I've broken the ice. I don't know if I did this right. What'd you get?
Oh, yeah.
Why would you go for the first one?
Yeah. A over
Sign of
sine of
right.
I hear some good stuff. Keep talking it out. Hearing someone explain it is so much more beneficial than just seeing the solution. You guys know that. Keep
I
going.
agree, but why do I plug in C? So I should.
No, you're adding 65 and 35 and then you're trying to put 80.
Which is 80.
Yeah.
That's how you get that.
Yeah, and so now let's see.
Hey, double check it. You guys agree?
Yes.
I like this section.
Not bad.
I like this.
So far.
Now, we haven't gotten to the ambiguity case. Like, he's gonna get a little funny. It's not impossible. It's not impossible. Alright, any questions though?
Hey.
Plugging in calculators, we're okay. Rounding error, we're avoiding because we're trying to use the nice one as long as possible. Okay. Pause. Pause. I just want to make sure that you guys are setting this up correctly. Go ahead and write this. Leave the blanks. But then don't wait for me. Go straight to trying to plugging this into law of signs. You've done the law of signs 2 times now. Okay? Write down the ambiguous case. So there's something at the top of this page that says, wait, something is different. Like there's actual notes for this. Ooh, it says painful case. What's going on? Not impossible, just a little bit more painful because you guys are like, oh, it's easy. I'll plug in the formula. I kind of got my bearings in the sense that I kind of know what's going on. Okay, tackle this problem. Now, first of all, it's not painful because there's a minutes. You guys know what I mean by minutes? Okay. But that's not the point. The minutes could have showed up in either of the other examples. You guys just know sometimes with degrees, they have like a partial degree, especially if you're talking about like navigation and GPS and latitudes, longitudes, those sorts of things. So, I was even watching, what was I watching? Oh, Psych is on Netflix, so I've already watched them all. So I was just like, it's something silly, I've already seen them, I can just only half pay attention, it's light, and anyway. But they were out on the ocean for something, some seal had died. Anyway, so then there were like these latitudes and longitudes, and I'm like, oh hey, look, degrees and minutes, like it was right there. It didn't show seconds, it actually showed decimal minutes. But they were trying to find the latitudes and longitudes to where this murder of a seal had happened. Anyway, long story short. Yeah, it was pretty sad. Well, they didn't. Some Gus did, some other guys that were trying to, some sort of shipwreck, airplane crash, steal diamonds, I don't know.
So some random seal in the ocean.
Well, it wasn't random, there was like a, that's not the point. The point was the latitudes and longitudes, go website. The latitudes and longitudes had degrees and minutes. So it's a thing, guys. Like it's right there on the ship navigational system. So how do we get the minutes? That wasn't supposed to be the painful part. How do we get minutes in this guy?
How do you just put that in?
You could be super snazzy and say like, whatever, I know what minutes are. I'm just going to do 2 and 45/60ths. You could do that. 2 and 45/60ths for the degree. You could be super snazzy and just ignore the minutes thing. Or where are minutes in your calculator? Second apps. Second apps. Second purple button. Second apps. You can just do 2 and 45/60. Because it's 60ths. Each minute's a 60th. That's not the painful part. Okay, ready, set, plug in the law of signs. 2 and 45/60ths, or you could use the little second apps to put the degree mark in the minutes, talk in your groups if you're stuck. But guys, just plug into the law of signs. See what's different on this one. It's possible to plug in. Go. Start your group. That's okay. Plug in. Plug into the formula, just like you did on the last one. Plug into the formula, just like you did in the last one.
Oh, it's because you have two dots.
Yeah. Take the over little b. Little a. Fine. Wow. So, this is the rest of this. Word.
Has anybody figured out what's weird and different? What's missing? Ooh, an angle. What were missing on both of the other examples? Sides were missing, right? So it doesn't get any more complicated when you have to solve for an angle instead of solving for sides. How did you guys plug in? Let's just see if you plugged in correctly. Okay, what are we missing? Angle A and angle C. And then we're also missing side C. Here's the dilemma. We can't use C at all because we know nothing about it. And we can't use angle A to find angle C because we don't know, we only have one angle. We can't do the whole 180 minus because we're missing two of them. So when you guys went to plug in, the only way that you could have really legally plugged in, even though you might have written it the other way because you were used to the other direction having the side on top, that doesn't make it wrong. But you needed to use side B with angle B, right? You had to use those two. And then the only other number that I knew was A, so I had to start here. Once again, you could have written them the other orientation, not realizing. Remember how I like to write the unknown one on top? But when you guys went to solve, didn't you have to move 4.5 to the other side? But the struggle is, even then, you weren't done. Because, A is not yet alone, right? How do we get A alone even after we move the 4.5 to the other side? Yeah. So, what do we got? 4.5 is to the other side. We have sine of 2 degrees, 45 minutes. Do you guys find the second apps where the minutes are?
Yes.
Did you remember they have to do 2 degrees with a degree mark and then the minutes to make it work? You have to actually do the degree mark first, so 2 in the little degree and then 45 a little minute. But even after you do that, the struggle is you still have to do sine inverse. Now here's the struggle. When you do sine inverse, and I'm going to put a little right here, case 1. Using sine inverse. Okay. To get rid of sine, you do have to do sine inverse. I totally agree with that. So if you come up here and if you do sine inverse of both sides, for case 1, what you're going to do is say, hey, okay, I know that A is equal to, or angle A is equal to, sine inverse of that whole mess, which is 4.5 sine of 2 degrees, 45 minutes, and that was a little 5, even though it does not look like one at all. Anyway, all over 6.8. Who's already done that? What did you get when you did sine inverse of perfectly 4.5 sine of 2 degrees, 45 minutes over 6.8? 1.819. Are you guys in degrees? Sine inverse? Hold on, double checking. I'm going to do second sine, sine inverse. I'm going to use my nifty little fraction thing to make it all nice and pretty. 4.5 sine of... No, not radian, degrees. All over 6.8. Okay, 1.819. That's a very tiny eagle. Very small, huh? You really weird, very, 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 very scrunched triangle. Kiddos, how do we find angle C?
180 is.
That, the whole number for angle A, and then
Never
the
mind.
number for angle B.
Okay, so 180 minus, good. Lainey said something important. She said the whole angle for angle A, so don't round it. Go steal the full decimals that you have up above. And then we also need to put the 2 degrees and 45 minutes. Which is 175.431.
Yes.
Or 43 if you're rounding to 2 decimal places. And then once we have 2 angles, what are we able to go do?
Find side C.
Find side C, because then we can go ahead and plug in. Now I'm going to probably still use this guy, because I don't want to have to go back and steal all the decimals. That's kind of messy to me. And it does introduce a little bit of error, even though the decimal places are way expanded. But I'm going to go ahead and still use my sine of 2 degrees, 45 minutes, all over 6.8 equals my sine of, oh wait a minute, do I want to write it like this? Don't I already know what C is?
Yes, you do.
Okay, so I'm going to go ahead, it just saves us a little bit of mental work, which you guys normally like to do. I'm going to put the little C on top and be like, oh that's right, I want my unknown up top. I'm going to write my 175.4305, what am I trying to show you? Don't round it, right? And then I have my 6.8, coming back to this guy, over sine of 2 degrees, 45 minutes. Now I can solve. Has anybody gotten ahead of me on this one?
Yeah.
Cool. Lainey, I'm just going to use you to check my answer. And the rest of you guys check me as well. Because just because 2 of us agree doesn't mean we're totally right. Just the odds are we're probably doing pretty good. 45 minutes. What'd you get, Lainey?
11.291. Nice.
I agree. Here's the dealio. Does it make sense that my angle A is super tiny? AJ, I'm coming to your question in just 1 second. Do you agree with our answers?
I don't know either. I will see.
Dude, yes.
Okay. Then give me a second. First of all, angle A was really weird. Like, a lot of us were like, what? 1.8? I don't get it. What's wrong? Radian mode? No, we were fine. We were degree mode. Why does it make sense from the given information that angle A would be so small?
Because it's a very small angle.
Angle B was really small, right? And what was side B, the opposite side from the really tiny angle? 6.8. Wait. How big is A's side? Smaller. So A's side is smaller. What has to be true about A's angle?
Small.
Okay, so it made sense. It was okay. It was weird, but it's okay. Side B was 6.8 across from the very tiny angle, so 4.5. Man, that's even smaller. Okay, so 1.8. Now, George, you just had a light bulb moment. What'd you figure out?
What?
What'd you figure out?
Oh, dude, I feel like it's just gonna be really dumb, so I'm not even gonna say
Okay.
it.
So, a few people were stuck on how did we get angle C? Whenever you have 2 angles and we know it makes a triangle, subtract from 180. So what we did was 180 minus the 2 degrees 45 minutes and 180 minus the 1.89, but with all the full expanded decimals, which was 1.89460079. So remember, if you have 2 angles, always find the third by subtracting from 180 the other two that you know. Then once we had angle C, we plugged them in and solve. Okay, here's the dilemma. This one is an example where, given SSA, if you guys were to actually draw your triangle, we have, I know, shush. They're being noisy. Given our triangle, we were given angle B, which is this guy. We were given side A, which is this guy, and we were given side B, which is this guy. Angle, side, or side, angle. Ooh, that's the dangerous one. That's the one we're not supposed to use. That's the one that has to do with the donkey, right? So, what do we do? Well, we were able to solve it. No big deal. What was the problem? I don't get it. Is it a possible triangle? Yeah, that and that make 180. This is one of the cases where there was only one possible solution. There was only one possible solution. You're like, I don't get why was there only one? Like, we solved it and there was an answer. So sometimes we solve it and there aren't any answers. Yeah. Sometimes we plug in, and when we go to plug into our calculator with second sign, wait a minute, sine inverse only works when it's between 1 and -1. So if we ever get one of these divisions that's greater than 1 or less than -1, it'll be an impossible triangle. My calculator will tell me error. So we could get an error, and we could know there's no possible. But here's the struggle. How can we, bless you, how can we tell? How can we tell if there's two? Well, long story short, we're going to look on Monday at case 2. We always, when we have SSA, as long as the first one works, pause, we have to check 180 minus sine inverse for angle A as well. But guys, if I did it in this one, go ahead, back up. If I did it in this one, why does it not make sense that angle A could be 178.180? Why would that be impossible? So
The size is too small.
this guy plus that guy greater than 180. Bye guys.
Spanish, take
Come back to your homework time. We'll back to school during lunch. You can play with a lot of signs and have less homework. You plan on it? I plan on it?
No, I'm just asking a question because Lauren wanted to know how long you were staying. She really wants